colleagues. My name is Kanat Tilikeyev. I am a senior research fellow from the University of Central Asia, and on behalf of the organizers of the conference, I want to say hello to all participants of our online session, which actually started prior to official opening of the conference, which is started tomorrow. So thanks a lot for your participation. I am sure it will be extremely interesting presentations and feedback and questions and comments. And now I'm happy to say that Michael Brody will be moderator of today's sessions, and floor is yours, Mike. Please.
Okay. Well, thank you, Kanat, for the introduction and the greetings from the conference. And hello, everybody. And first of all, I'd like to say there's several of you who I know through emails, and I'd never seen their faces before. And to put this in a little context, there's a group of us here, and we organized 2 panels on climate change in Central Asia. Sort of starting from the higher regional global level issues down to very local impacts and what we may have to adapt to. And the panels were organized, therefore, in 2 separate panels, from the kind of global regional, which is what this panel is, and this one's online, to the more local issues. And there are several people here who are on that panel, and that panel will be in person. We had originally hoped this one would be in person, but some of us got stranded on the wrong side of the ocean schedule-wise. So today, in our hour and a half, we have 3 speakers, so we'll have plenty of time for questions and discussion. And the order of the speakers will be, first will be Peter van Oevelen, who is the director of the international GEWEX project, and he will be explaining what that is in the talk. And second, we will have Erkin Isaev, who will be talking about looking at various forms of essentially what we call climate proxy data to look at the climate models and what insights that may offer. And then finally, our third presentation today will be from the economist Alexander Golub, who, like me, is here in the DC, Washington area. And he's going to talk about how do we know, in a sense, how do we know that information is worth getting? What is the value of information, particularly from these remarkable tools that people like Erkin have mastered of remote sensing? We all know that water is this gigantic issue in Central Asia, future water resources. And therefore, Central Asia, like much of the world, will have potentially tremendously high adaptation costs. So what do we need to know? What's worth knowing? What is the value of the information that we could get that will help us adapt more efficiently and effectively? So we have this theme today from sort of the more starting at the regional, global, what can we find out? How can we find this out? Down to some things that we already know, to the what's worth finding out. And then the in-person session, which is tomorrow, some horrible time for us in Washington, but I may still try to join. What does it really mean on the ground? Because this is climate change is an issue that doesn't go away, even if we slow down our emissions, and we have to learn how to live with some of the consequences. So with that, I'd like to start the actual session. And any speaker can take up to 20 minutes. They don't have to. And then we'll have time for specific questions about each talk at the end of the talk. And then we should have time for general discussion later on. So Peter, if you would, please.
Yes, thank you, Michael. Thank you all. Good seeing you. Let me see if I can share my screen. Let's do it this way. Okay, I cannot see you any longer, so nor the time. So Michael, if you can give me a 5-minute warning, then that would be helpful.
Sure. No problem.
So hi everyone. So I'm going to talk. It's a little bit of a promotional talk. and it's a promotion that's already been ongoing for a few years now, and COVID, of course, messed up quite a bit of it. But the Global Energy and Water Exchanges Project, the World Climate Research Program, is interested in starting a Central Asian Regional Hydroclimate Project, and what that exactly is, I'll come to that. And one of the things is to support sustainable development goals in the international context. And we do this together with START, which is a capacity development project also based in the US. So GEWEX, the Global Energy Water Exchanges Project, is a project of the World Climate Research Program. It's a supports international research collaboration in the field of water, weather, and climate. And so we're not a funding agency. I would like to stress that. We're really about international research collaboration and trying to facilitate that. And the purpose is to better utilize capacities and competencies in the area of water, weather, and climate research, and to support the development of resources and capabilities to enable state-of-the-art relevant climate research and observations. And in particular, that latter aspect, observations, is the key of where actually GEWEX started. It started about 30 some years ago, the early 90s, as part of the Earth Observation Systems, EOS, strategy of NASA. And at that time, WMO, the World Meteorological Organization, and in particular the World Climate Research Program, felt the need to use these new, at that time, satellite observations for climate research. And GEWEX was in particular sort of put together to look at how satellite observations can be used for climate research, in particular over land. But in general, GEWEX looks at global data sets. And so we were one of the projects that actually started looking at climate data records from satellite observations. And a good example is the Global Precipitation and Climatology Project, as well as, for instance, the International Satellite Cloud Climatology Project, two of some of the longest running satellite-based climate records. So GEWEX in general supports the UN Sustainable Development Goals. Obviously, we also try to work within the framework of disaster risk reduction, and of course, the overarching for us convention, the United Nations Framework Convention on Climate Change. But ultimately, when it comes down to it, the GEWEX community focuses on process understanding and how climate is changing, and what are the drivers of that change, and how can we understand that better. So the priority areas are improved understanding of the impacts of climate variability and change on water availability and food security across mountain ranges and river basins, in particular, of course, now in this context in Central Asia. We have for that what we call regional hydroclimate projects, and these are locally driven, run by regional scientists to support these type of activities. So we really want to bring together the local scientists and stakeholders within a certain region, and to see how we can collaborate better and how we can actually use the international context to support these activities. And that means to actually link to other activities, similar activities in other regions of the world. And for us in particular, looking at Central Asia, we noticed that we hardly have actually engagement there, which is surprising given what is going on and given the situation. So we really like to better serve that region. And in particular, because Central Asia is unique for its water resources, its conservation issues, and because of its vulnerability to climate change. And in that context, weather and climate extremes are, of course, very important. I don't like personally the word climate extremes. I prefer just weather extremes. Basically, weather is the ultimately what we experience. Climate is something that is more of a statistic in my view. But anyway, so droughts, floods, that sort of thing, heat waves is what we're looking at in that context. And the other thing in Central Asia, because of its mountain ranges, some of the highest in the world, as well as the largest endorheic lake in the world, it has some really unique processes going on, and we like to better understand what is going on with respect to that. So Currently, we have several regional hydroclimate projects going on. A nice example is Andex, which is in the Andean region in South America, which basically covers the whole 7,000 kilometers of range. And that project started about, let's see, 5 years ago. So they're also rather new, and they're really starting to get working. And this is one of our sort of newer projects. Similarly, the Southeast Asian RHP, which is called AsiaPax, is started similarly about 5 years ago, which will look at particular precipitation and monsoon processes over the Southeast Asian maritime continent. Then we have something together with the Chinese, the third pole environment. And these are sort of the newer ones. And then the more established ones are global water futures over Canada, primarily Baltic Earth over the Baltic Sea. And Baltic Earth is one of our longest running regional hydroclimate projects. In general, these projects last about 10 to 15 years. Baltic Earth actually started in 1995. So that's well over 25 years already. PANEX, which is now a regional network, and the hydrological cycle in the Mediterranean experiment, HYMEX, which actually just concluded last year. And they're working on a follow-up experiment in the same region. And then GEWEX, which also lasted until 2 years ago, which is more of a regional network. So we're looking at sort of spread around. We have, since the early 90s, since 1992, we have these projects going on. And one thing that's nice is that it enables us to work together with experiences from different parts of the world. Sometimes similar things work in different areas, but a lot of times it doesn't. And we try to figure out why that is and how we can help each other figuring out how these things work. So what we need to do from a research perspective is look at the observations, do an observational synthesis. What observations are available? What scales are they at? How long are they available? And use that to understand the key processes. And with that, of course, with that understanding is modeling is important. Trying to model it to understand it, but also then to say, okay, how can we go from understanding to prediction and projection? And with that, of course, we need to do capacity development in many regions, and in particular in the lesser development countries, but it also in the places like the US, which is well funded. We still need to do capacity development because observational networks are at the core of it, and wherever we go, these things need to be supported and expanded if possible. We also like to work on the human capacity, what is available, the technological capacity. Okay, what can we do? What is locally available? What can we import? And international connectivity, of course, is important in that context. The capacity development part is in particular the expertise of START, as I mentioned before. So to show some of the things that we have ongoing in the high mountain regions, this sort of overview, sort of a poster that I put into slide. And as you can see that we are currently with Global Water Futures looking at the Canadian Rocky Mountains, in particular with Andex, we're looking at the Andean Mountains. With PANEX, we're looking sort of a little bit at the Eastern Alps. With the third pole environment, we're looking, of course, at the Hindu Kush Himalayan region. So now we're looking at, okay, what can we start in the US again? Similarly, looking at the US Rocky Mountains. We're also interested in East African. It's also an area that relatively for us is underrepresented, although we've had projects in the past. As I pointed out, Central Asia is really on the top of our list to really engage more with the community. And hence, this is sort of also, if you're interested, approach us and see how you can connect. And we'd like to really hear from you. So what is in it for the region? Access to top-tier international network of climate, weather, and hydrological scientists. Access to state-of-the-art modeling. And here I'd like to sort of point out the 1 kilometer, the convection permitting modeling type of activities. And that means, like with Andex, they're actually having both the Met Office, the UK Met Office, as well as NCAR run these models over South America for, I think, 30 years. So that's pretty unique. Capacity development, human resources, hardware, software, increased regional capacity to provide improved climate information. I think this is a very important aspect. Right now, downscaled information from climate models is really coarse, and in particular in high mountain areas, often downscaling from 25, 50 kilometers down to the ground has issues and complications with it. So you cannot just do that straightforwardly. So that's where we like to improve. Large-scale regional collaborative efforts, basically sharing of knowledge and data, is something that we really support, open science. And that have we been doing for over 30 years, because I think that's the key to actually any successful collaboration, is actually sharing knowledge and data. And the efforts, from our point of view, should be regional led and run. So basically, really, the scientists in the region should do this, and we are there to support that. So why Central Asia? As I point out, for us, we're interested because we don't have too many connections there. But at the same time, it's also a data poor region. And in that sense, data is both access and also people and, as I pointed out, observational networks. So what can we do to really improve that? And this could be, and I like this word, testbed for economical efficient adaptation, right? This is a region that is very sensitive to climate change. So what can we do? And I think there are some tools here that can be developed to better understand what policies, etc., need to be implemented. So what are the major climate issues? Melting glaciers are a big one, and that are the foundational region's water resources. But with that melting becomes, of course, the change in regime, going from basically more snow-based to a precipitation-based type of water resources. Glaciers are, of course, primarily located in only 2 of the 5 countries that I just pointed out, Kyrgyzstan and Tajikistan. The summer temperatures are increasing and even getting hotter than they already are. And with that, of course, we have the vulnerable agricultural systems, and particularly downstream. So this is interesting, is to see that although the glaciers are primarily located in 2 of the countries, the water resources of the region are very much interconnected, and hence we cannot do this by country. We really have to look at it in a larger regional context. With that also is that it's not just about humans and agriculture. Of course, it's also about habitats and critical ecosystems. How do we preserve that? How do we preserve local cultures? And how do we preserve, for instance, the environment? And particularly big cat conservation, snow leopard, is, of course, a very nice thing to work on. To showcase some of the reasons what is happening, and we can show some of the seasonal and annual temperature anomalies in the region. And from this project, you can clearly see, when you go to the right, is that temperatures are really increasing. And there is no doubt that the regime, temperature-wise, is changing. So is that also the case when we're looking at precipitation? And then it becomes a little bit more difficult to really. Okay, great, thanks. I'm nicely on schedule. It's much harder to actually show that in precipitation. We do see changes, but how consistent they are, it's not as clear-cut as from the temperatures, but things are changing. And in particular, when you're looking at then what the consequences are for runoff, this is a nice figure showing the different managed and unmanaged basins. And on the left, you see the dams, the reservoirs, and the observational points. But I want to point out actually more to the right, where some of the conclusions are put down, is which basins, which of these stations have a significant increase, which have a significant decrease. And one thing that you immediately notice is that there's quite a stark distinction between the two, and they're clustered. That's one. You also notice is that actually the limited number of observations in Central Asia, that, of course, is something we like to improve upon and understand what's going on, because we need those observations to say something. But as you can see from this picture, in particular the top right, certain parts are drying, and the top figure, basically, I wish they had used different color schemes, because significant decrease in runoff is in blue, and the increase is in red. Not sure why. For me, it would be other way around. But as you can see, in particular in Europe, Northern Europe, you see a significant increase in the northern part, but in the Alps, you see a significant decrease in the mountain regions. Over the US, it's a much more of a north-south distinction similarly, but since the Rockies go from north to south, you can see a decrease, an increase, and a decrease when you go from north to south. And similarly, over the Andes, you see a little bit of a mixed, go from south to north, you see a decrease, in particular in the colder part, then an increase and then decrease. And you can wonder what that increase is. Is that an increase from glacial melt? And is that only temporarily in this period from 1980 roughly to 2018? Or you know, is it also a change in precipitation regime? And as I showed in the previous picture, that's not as obvious. So that requires actually more research. And another picture from GRACE satellite data. GRACE measures basically the gravity and changes in that, and you can correlate that to changes in particular total water amount. I'd like to point out this part where, in particular, Central Asia is a very, mixed region with drought obvious, where it's red, but also some areas that are getting wetter. This is over a couple of years, so it's not as long period. So you have to see this more in a shorter term context and not as much in a necessarily climate context. But these type of information can really, in combination with precipitation observations and runoff, tell you something about the processes that are ongoing. So what I'd like we to do, we started out with actually a survey of climate science and change needs in Central Asia, and I know that some of you contributed to that, so thank you for that. An online workshop as well, we did that in October 2021, and we really like to continue that, in particular collect more information on critical agricultural parameters that can be tied to climate scenarios, for example. When we are tying in our connections with CAREN, the Central Asia Regional Information Network. So we really try to combine our efforts in that context. Let me go back actually for a moment. So currently we were looking at how to continue this, and this promo talk is one of them, along with Michael and others. We really wanted to continue this effort and organize some more workshops, but ultimately we want to actually organize a community to work together so that we won't be needed anymore. That's actually the purpose. Ultimately, climate adaptation is sort of what it ultimately comes down to. The cost, of course, globally will be enormous, but in certain regions, it will be much more critical. And for that, we need innovative economic analysis to guide investments. And Sasha later on will no doubt talk about that. And regional hydroclimate project research can actually support sort of the physical, geophysical aspects and the biogeophysical aspects. But it can tie also very well into policy and other things. And this might be something that would be really worthwhile to investigate in Central Asia. And I think with that, I can conclude. So for more information, please contact me or Michael, and look forward to your questions. Thank you very much.
Thank you, Peter. Right on time. So if there are some questions directly related to this, please, we have a few minutes before we need to go on to the next talk. So
I'll stop sharing the.
Yeah.
Okay, let's.
So
It's stopping now.
Not quite yet.
Yeah, my mouse is, there we go.
It's still there. You just got out of it. Okay, all right.
Yeah. Well, if you have two screens, it's always a question of which one and where is your mouse pointer. And
so Okay, before we go to the next speaker, do we have any immediate questions about that presentation? Hello, Seth. Go ahead, please. Seth Fury at AUCA.
Hi, I'm not a scientist, kind of new to a lot of this stuff, but learning, but very interested in your closing comment about supporting regional collaboration and sharing of data. I'm not terribly sure what's actually going on here, but perhaps there are some models that you might suggest for us to the extent that you see weaknesses here. What could we be doing better to support regional collaboration of strategy, directions, and data?
Yeah, no, that's a good question. I mean, access to data, of course, is critical for any research. And what we try to establish is first a culture of trust, where people get comfortable in sharing data. I think that's always important, in particular in areas where it's not as common. And then the other thing that we really push for within our community is anything we do needs to be accessible by others. And the advantage you locally have, and that's sort of, I think, because the fear for research is always like, if somebody takes my data, then they're going to publish before me. That's one of those, there's old adagio that, keeps running through it. And we say, well, but hey, if it takes you that long to publish something, maybe, it's somebody else should have a chance too. But that's not the point. If you work together, you actually are much easier able to actually publish and do something with the data and actually get something out of the data. And the fear usually dissipates because they now notice that, wait a minute, if I actually collaborate, it's much easier to also get access to other people's data and actually do the things I want to do. But it takes time, in particular when it's not an established culture. But we have various different examples around the globe on how to establish that. I mean, as we do now with these workshops, we organize that sort of the first step, getting to know people, getting to know what people are doing and how they operate is really the basic step first.
If I could just briefly add, I think
Sure.
this would be a good topic of discussion also. Erkin, you had your hand up briefly. Did you want to ask a question?
Yes, thank you very much,
Then we will
Peter.
go to your presentation.
Okay, thank you very much for your presentation. Yeah, I'm fully agree with you that Central Asia is a big gap in terms of data. And my follow-up presentation will be about the data, reconstruction of climatic data. And for information, by the end of this month, I'm going to Japan to run the climatic downscaling model with a 5-kilometer resolution for all Central Asian region. And the output of this climate downscaling product we can use in your project, like run the hydrological model to assess future scenarios to prepare climate adaptation plan. And this is just suggestion for cooperation. Thank you.
Very nice. Very nice.
So,
yeah, that's great.
Yeah. Unless there's, by the way, Erkin, we've had our eye on you for a while now. So, but, so unless there's a very detailed question for Peter, let's move on and we'll have Erkin go ahead. So I see no immediately raised hands, but we're going to have a lot of stuff to talk about after the all three presentations. Okay, Erkin, please go ahead and I'll give you a 5-minute warning.
Okay. Can you see my presentation?
Yes, yes.
So let me tell me about briefly. My name is Erkin Isaev. I'm a research fellow at the Mountainside Research Institute at University of Central Asia. And this research we conducted within the framework MOU, which we signed with government of Kyrgyz Republic in terms of cooperation in climate change, air pollution, water issues. And do you know this year of mentioned by our president, year of mountain ecosystem and climate resilience is as an United Nations year. And within this year, we conduct this research. And as Peter mentioned that in Central Asia, there's a big gap in data. So we start to, first of all, To prepare national adaptation plan to climate change, we need to choose the best climate models, best scenarios, and by using these scenarios, prepare the national adaptation plan. And as also Peter mentioned it, climate model global has very hoarse resolution, spatial resolution, and it's very hoarse to use in a mountainous region, such in Kyrgyzstan. And this research was the main aim of this research was first of all reconstruct the hydrometeorological data by using 3 rings information, dendrochronological information, and by using this reconstructed data, 1 century data, choose the best climatic models, climatic scenarios, and in terms of different climate model incorporation panel, phase 5, 6, and Cordex experiment, and then conduct bias correction method by using the ground measurement data. Oh, I'm sorry. Here, as I said before, the Kyrgyzstan very mountainous country, 94% is a more than 1 kilometer elevation mountains, very different climatic zones, very different agroclimatic zones. That's why the climate model spatial resolution plays key role when we are using this kind of modeling systems, even for climatic, for hydrological model. And so what kind of method we use? This kind of methods: correlation analysis, trend test of Mount Candle, machine learning approach, and bias correction methods. And we use it tested more than 7 machine learning approach to reconstruct hydrometeorological data by using 3 rings, and choose the best one which works to reconstruct data. And for verification, we use this kind of metrics: root mean square, mean absolute error, clean couped efficiency, and also Taylor diagram. And this kind of 3 rings, we together with National Academy of Science of Kyrgyz Republic, Institute of Hydropower, and Institute of Water Problem and Hydropower, they collect more than 903 samples, but only 33 samples were undamaged with this float and mood floats. They collect 800 damaged floats to reconstruct the floats and mood floats, and to analyze the glove, and 33 undamaged trees. We use this 33 undamaged trees near the meteor station data samples. And this kind of tree, this kind of meteorological data from different meteorological station, we use it, and hydrological station data, and also this kind of pizza, abes, L crust, 31 tree samples we use it. And what we did, we reconstruct from this period for the meteorological station data for precipitation temperature, and also discharge, monthly and yearly discharge for this river hydrological post. And first of all, we found that cross-correlation analysis, which parameter, meteorological parameter and 3 rings correlated each other, and the blended red one is more correlated one, and we use this correlation, only correlated, well correlated and significant correlated parameters to do this kind of reconstruction. Here, the evaluation metrics of each 7 machine learning approach to do this reconstruction for the different metastation and for the different parameter, for example, discharge. Most of them random forest regression with hypertuning and XGBoost regression with hypertuning shows the best results, which we use it to reconstruct hydrometeorological data. And here we can see for annual precipitation, annual temperature, and for Baitik meteorological station and Baitik hydrological post, and water discharge, average water discharge annual. We can see that here's the reconstructed part, and here's the historical part, and here's the errors of reconstruction. You can see that temperature is increasing very fast, and the trend is significant. And at the same time, you can see that annual runoff discharge also increasing in this river. but temperature, but precipitation is the same, neutral trend. And we can say that if the precipitation is the same, neutral trend, temperature is increasing, and discharge is increasing, we can calculate the contribution from the glaciers melting. And we have a huge massive of glaciers in the beginning of this Kazalsu river basin, and this contribution from glaciers melting, we can conclude. And here we try to choose the best climatic model which can simulate a real climatic situation, climate characteristic over the mountain region of Kyrgyzstan. And we use this SMIP6 models and SMIP5 model and Kordok experiment, all Central Asian domain experiment. And we want to contact, here's the special result much more higher than this global model. And here we can see that root mean square error and efficiency square, KGE, for the meta station by TIC and Alarcha. Here the SMIP 5, 6, and Kordok. The highest, you can see the green part, the highest score, the smallest error, we can see that Kordok's experiment shows, because the special resolution is plays key role in the mountains region. But SMIP 6 models also showed some good result due to this, include the new parameterization schemes in their model, updated model of 6 phase. And second, we introduced it and used the bias correction method to correct the historical data, climatic data simulated by this model. And we can see after bias correction, the reducing of root mean square error and increasing this index of efficiency. And multimodal ensemble mean also increase it in a significant part. And here by talagram diagram, you can see also the green part here. The errors reduced with for the mean, multimodal mean, and also for selected mean, multimodal mean. And in this correlation coefficient diagram, you can see that for precipitation and temperature, after creating this multimodal ensemble with bias correction, and this is selected. We selected only that model which show good results, and also model example with bias correction shows that it significantly increased the performance of model results. We can see that significant 95 increased for temperature and precipitation. And this is a discussion. What we did that spatial resolution play key role, and bias correction should be conducted if you have ground based measurement. We have to use this, and this kind of reconstruction is important. And to conduct and prepare national adaptation plan, we need to very good climatic scenarios, and that's why bias correction is important, spatial resolution important, and also data to do this kind of verification work. The long-term period data is very important. So right now we are planning to conduct the climatic downscaling for the Central Asia with the spatial resolution 5 km, and verify that result with this same method, and then conduct public lecture to our partners, which they can use this output of this high resolution climate downscaling products for national adaptation plan, for this kind of, as Peter mentioned it, hydrological and climate modeling for the future scenario, so water issues, and for agriculture and biodiversity issues. And thank you very much. And this work, result of this research, we publish it in this Journal of Water of MDPI. You can find in this link. Thank you very much.
Okay. Thank you, Erkin. You were just getting close to your 5-minute warning. So do we have some specific questions for Erkin before we move on to our next talk? Actually, can you start unsharing your screen, Erkin? Unless
Okay.
somebody... So, any questions immediately for Erkin? If not, oh, okay, we have on Peter.
Well, just a quick one. So, Erkin, are there any plans to extend this type of research to other regions?
Yes, thank you very much for your question. In terms of reconstruction of hydrometeorological data, yeah, we are now planning with Kyrgyz Hydromet because they have more than 35 meteorological stations with a different period of observation and more than 65 hydrological posts, also measuring precipitation and water discharge. And we are now prepared project proposal. Now we are waiting the funding. And for the other part of Kyrgyzstan, because as you mentioned, that Kyrgyzstan and Tajikistan, the water tower of Central Asia, is very important to future adaptation planning.
So I actually have a question. I was looking at one of your graphs quickly, but the Global Water Futures Group in Canada, they have at least one gauge on the Ala Archa. I think they're working with Kyrgyz Hydromet. Do you happen to know if the gauge, I think you had a gauge on the Ala Archa, if I read your table correctly.
Yes, yes.
Do you happen to know if it's the same gauge? Because we need to find out, because maybe there are a little more data.
Yes. Yes, they have in this Alarcha Valley, the Kızılsu River Basin, two meteorological stations and one hydrological post. And I think Baitik meteorological station has more longer period of observation. If they are using Alarcha, it's a short term. But we did reconstruction more than 95 years.
Okay. Peter and I should help you find out if that's one of the Canadian installed stations there or not, or whether there are more data still.
Mm-hmm.
So, okay.
Okay.
Any other questions? Because if not, Sasha, the floor is yours.
Thank you, and thank you so much for opportunity to participate in this conference. And good evening to everyone who is on another side of the ocean. And Peter, good morning, especially to you, because I think in your region it's very early morning. So anyway, let me start my presentation. Well, today Peter and Erkin gives us some glance on data that are available or could be available in the region, and Peter gave very good global overview, and Eric gave us some perspectives how you can reduce uncertainties, and reduction of uncertainties is something that I'm going to talk about today, and it's a very important part of decision-making process. But even more than that, it's what we need to understand about information. That information has value only when this information is used. And in case of climate change, of course, it's not a secret that we must adapt to climate change, even if we like it. Climate sensitivity is not that high, and if we are lucky, and carbon emissions will be reduced drastically over the next 30 years, still residual carbon accumulated into atmosphere, it's going to be a problem for us and for the next, at least for the next couple of generations. So adaptation is a reality. Well, by the nature, all we know about climate change is our knowledge up to probability distribution. In other words, all our investment decision must be made in context of uncertainties. And when we do investment decision, well, we need to calculate cost and benefits of this investment. Otherwise, it doesn't work because there are several competing priorities, and to justify why this dollar should be spent to adapt to climate change versus why this dollar should be spent to improve healthcare or education, well, it's a competition, and you need fair system of indicators. Well, when we're talking about uncertainties and depends, and by the way, most economists who's dealing with climate change, consensus among them that adaptation must be a part of any development strategy. It should be kind of weaved into that development strategy. So we cannot avoid a situation when we need to measure effect of adaptation in terms of return on investments. And what is available? Several methods, like one of them is robust decision making, and that's a method you use when you really have clear goal. For example, if you determine to save Aral Sea, then well, you need to consider a feasible strategy how to do that, and regard of cost is not that important. However, if you'd like to improve irrigation technique, then you can measure risk using real option analysis, and I will tell you in a minute what real option analysis means, and especially well, several applications, and I don't mean to create publicity, but Michael can tell you more how we use real option analysis to measure efficiency of lower water technologies in Uzbekistan. So anyway, at best you know your impact of climate change, and therefore benefits of adaptation up to probability distribution. And of course, probability distribution could be quite large, and that's damage here, and the probabilities of this damage is there. And of course, it's asymmetric, it has right tail, and we call it tail risk or fat tail risk. When you dealing with investment, and when investors see such a distribution of irreversible investment, like you need to build a new dam, for example, and you don't know what's going to be actual impact of climate change, and therefore what's going to be benefits of building of this new dam. Well, there are a lot of incentives for you to postpone investment and to learn first what is actual climate change and what's going to happen, and what would be your actual return on investment. Then you actually stuck with your investment decision. You cannot commit those investments before you learn more. And here where we get to the value of information. Reducing uncertainty, you reduce option value. And by the way, what is option value? The idea of using option pricing and option methodology comes from financial markets. And option in generally is a contract when you have a right but not an obligation to buy some assets, or in case of real option, you have opportunity, but not an obligation to commit irreversible investment. For example, you have a blueprint, you can build a dam to save water or do something else. I don't know, pick an example, but you don't have obligation to do that. And you have time to learn what would be actual return on this installation and what would be investment. But then, of course, delaying this intervention, you still suffering from droughts, for example, but you really don't want to commit even high investment before you have better certainty. So learning reduces uncertainty and make your investment decision possible sooner than later. Therefore, real option methodology could be used to optimize timing of investment and also to just to highlight value of assets that you create. And of course, it could be used to assess value of information. For example, if you would like to implement expensive long-term project that gather information, like, for example, as observing system, you actually, with my colleagues from NASA and from Research for the Future, we use this methodology to conduct cost-benefit analysis of a new Earth observing mission called Clario. It's still, unfortunately, wasn't launched because of several things, like funds was cut, and now funds are back online again, and we still hope that this mission will be launched. But again, this mission would help, among other, to learn much faster about actual sensitivity of climatic system to accumulation to all of the greenhouse gases. And using real option analysis, we calculated that actual value of this information that the mission could gather would be 20 times more than cost to launch this mission. Without understanding option value, you wouldn't do these calculations. And it was very helpful to still keep this mission with delay, but online for implementation. Well, as I said, in smaller projects like irrigation, you calculate risk-adjusted cost of investment and risk-adjusted benefits. Like dripping irrigation is much more expensive than current practices, but extremely high option value would justify that. Okay, so how it works? As remember, I showed you this first initial distribution, and here it's outlined with that yellow greenish area on that graph. But in fact, this distribution is a combination of, for that example, I used 3 different distributions, and I assign equal probability for them to happen. And really, if you look at those 3 different distributions that showed with that outline, they are quite different. And if you follow one of them, then you would have one investment decision. Like in one case, climate change appears not as dramatic, but in other cases, it's much more dramatic. So anyway, you really make different investment decision if you end up with this distribution, that distribution, or this distribution. And how to know? Of course, hard way is to wait until climate change struck you, and then try to make decision. Of course, it's a feasible strategy, but it may have a lot of regrets embedded in this strategy. You better use your knowledge and try to extract vital information that helps you to distinct among the 3 distributions. And you can use forward-looking analysis like Cordex data set that gives you quite a lot of information gathered across different models and across different carbon emission scenarios. Well, uncertainty could come from, because we don't know what would be actual emissions of greenhouse gases. So one source of uncertainty. Second source of uncertainty, climate sensitivity, how this the global system would respond to accumulation to greenhouse gases. Third source of uncertainty, how actual, and that's Erkin work fits into that, how it's gonna happen on the ground, what is actual sensitivity and vulnerability of particular ecosystems. So all of that helps us to take a glance on the future, and then try to, based on learning and accelerating learning using satellite data on one hand and using ground observation on another hand, just to narrow this uncertainty and make decision. And well, again, here I just, as an example, showed you different parameters of this for distribution, like B1, B2, and B3. That's what you get. Only one of them is true. And you know that sooner if your learning process organized well. And initial distribution has widest range of uncertainty, and that's what you start your kind of priors your distributions. And what I'd like you to look at is using analysis of this distribution, applying option value, you get completely different estimates of investments that should be could be justified to put into adaptation. It's numerical examples. Think about it like investing $1 billion, and if you don't know nothing, it's, well, you said, okay, based on this distribution, I think I can invest $4 billion. But in fact, this investment will be not enough if you have the highest case of expected damage, and would be too much if actual impact is not that significant. Also, I have another line, and that's when you're dealing with irreversible climatic events that you cannot compensate in time. Like irrigation, you can, but I wouldn't go with such example like Aral Sea, but something else like building dam. Even if you can build that and still prevent future damage, but you wouldn't go back and prevent damage that happened because you didn't build it in time. So that's taken into account tail distribution. So what is also important about application of real option analysis in contrast to traditional method of application of expected value. When you use expected value, you collapse all those distributions into one number. And, therefore, you lose valuable information about shape of the distribution. Application of real option analysis gives you a chance to take into account shape of the distribution, and some distribution may exhibit high variance, longer and fatter tail in the distribution, and application of real option value methodology using formulas, option pricing formulas of different sophistication would let you to take into account all those parameters of this distribution. Michael, how I'm doing?
You're doing perfectly. I was about to give you your 5-minute warning.
Okay, so then I think I'm coming to my conclusions. Well, so what should be next steps? On one hand, immediately, like if let's say you submitting proposal to justify efforts to gather information, to speed up learning, you can use this option value to give some kind of glimpse on the benefits of this project. Like for justification of project itself, you can use this real option evaluation methodology. Like we did that with NASA and with Research for the Future to justify benefits of Clario mission. And as I said, results was quite amazing. And actually, before that, NASA didn't use cost-benefit analysis. Mostly what they would use, they would say, well, we have very good ideas, so how much it would cost? So they at best used cost efficiency analysis. So really, there are several gaps in simply in relation and in communication. Because look, when you're talking about something big and expensive, you're dealing with politicians, and politicians would like to know that what benefits gonna be. So real option analysis gives you this kind of information, and it could be used just to value, let's say, something that has immediate implication, like benefits of early warning systems. So I have quite experience using real option analysis to justify early warning systems in Southeast Asia and in Africa. And really quite small investment would generate quite a significant value, but you only capture that when you apply this methodology. Then, of course, for adaptation strategy, and adaptation strategy is by nature, as I said, is de facto, and there will be even more of that, part of any development strategy, especially in vulnerable to climate change regions. So adaptation is becoming, therefore, part of mainstream investment. And you'd like to not only to use public funds for adaptation, but you'd like adaptation to be embedded in private investment projects. For example, in construction, like if you build a new house, it supposedly would stay for the next 50 years or maybe more. And it will be vulnerable to future climate change. So what should be kind of embedded improvements in the project to address future climate change? What investment could be justified? Well, another example, vulnerability of power generation sector, like this methodology was used to assess vulnerability of power generation system in Germany. And I can give you more and more examples, like on a global level, to use real option analysis to estimate social cost of carbon, risk-adjusted social cost of carbon. But here, again, I say that most pressing and next step is to try to do even back on an envelope estimates of value of new Earth observing system, value of coupling that with ground observation. And I think this methodology would help. And only what you need to do to implement this methodology, you need to compute a couple of distributions. And one distribution, probability distribution of benefits or damages, actually, to different side of a coin. And then to have some ideas how a project could improve learning process, like it was with Clario mission, more precise equipment, reduce narrow of observation, and then speed up learning process. And what would be kind of distribution of avoided damage, because we made adaptation decisions sooner and more tailored to what we believe is actual basis of climate change. And of course, I may be criticized because you can say, well, still gonna be residual uncertainty even after we learn something. Well, yes, it will be, and it will be still unresolved option value, and it still will be some kind of disincentive effect for private investment, but learning would significantly reduce this disincentive effect. And I think it's important to take that into account, planning next steps to improve learning about impact of climate change. Thank you.
Okay.
I think I need to stop sharing screen here.
So thank you, Sasha. And we already have a question comment in the chat box from Rena. If you like to go ahead and also ask that out loud.
Sure. Thank you very much. I'm actually out in Bishkek, so it's quite late in the evening here, and it's a very fascinating session. So thanks to all the speakers. A very important point, I think, and something that we sometimes struggle with in terms of just making a really strong financial case. I think when we're looking at not just climate change, but from the natural resources perspective, and there are various frameworks. I'm thinking from a donor perspective, and when we're looking at sort of programs we deliver and the sort of interventions we choose to pursue. So really from that perspective, but curious to understand a bit more about the evidence base. I think somebody mentioned it right at the outset about the impact, I think, of the investment in monetary terms. It's sometimes hard to find that evidence. There's much grey literature there, but in terms of what's published literature, still I think there's something that needs strengthening there, but this may be quite a specific question. So back to you, but thank you very much.
Oh, thank you. It's an excellent question. And of course, especially when we're dealing with climate change, it's a kind of a chicken and egg. Because on one hand, we don't have much of, well, we may have a lot, but definitely not enough investment into adaptation. And most of positive effect of this investment will be in the future, because adaptation is a preemptive strategy. But I think you can get some understanding of actually post-factum analysis of adaptation investment. And I think what comes to my mind, the best gonna be building of dikes in the Netherlands, because all our interaction with nature is to some extent adaptation. Problem with climate change that this nature is changing extremely fast, and we need to adapt in much greater paces than we were adapting to just regular steady state situation with climate change. So I think it would be the best examples of a posteriori analysis. I don't know, Michael, maybe you come up with something else because your experience is in EPA, where we can get. Well, another problem is to build counterfactual scenario like with New Orleans. Just 2 years or so before this disaster happened in New Orleans, we were talking with Michael about insufficient protection against this flood. And it's, again, partly it's due to climate change, partly because they were very unlucky with that strength of hurricane. But in any case, there we have a kind of evidence. We would have counterfactual scenario vice versa in that case if protection was improved before. And so that's what's happening. I don't know, Michael, maybe you can add something.
Yeah, I'm happy to comment on that a little later. And Peter, if you want to eventually talk about the Netherlands a bit, because I believe you are from there. But I don't know who else has an immediate question for Sasha, so please go ahead and ask. And then Rena, I actually would like to ask you a question eventually, because you talked about various frameworks. So, but then is there a quick question for Dr. Golub? Well, I'll make a quick comment about Katrina, which until Hurricane Harvey in Houston, Hurricane Ian in Florida was perhaps our worst catastrophe hurricane in recent memory. But I used to work near New Orleans as a wetlands biologist, and I knew a lot about the flood protection systems. And if ever there was an underinvestment in a flood protection system, it was that city. And I think most people knew it at some level, but trying to get a poor city and a poor state to do the work independently of funding of our federal government is nearly impossible. Since oh well, Rena has to leave, but I wanted to hear about her other framework, so I'll have to get your email or something, Rena. So I think we know in a lot of cases we are underinvested, but this question of how much to invest is a very difficult question when you're looking at these magnitudes of investment. Thank you. These magnitudes of investments to protect places. And we're rich, I think, in the US, and we still don't do everything we might. And a lot of it's because we don't have a well-justified benefit cost ratio, which needs this kind of analysis that Sasha's been talking about to really come up with the numbers. So if there's no immediately specific question for Sasha, then we can just go into some general discussion now, any types of questions. And Peter, if you wanted to add anything, since he did mention the Netherlands.
Well, not necessarily, but
okay.
I do think it brings me to a question I have for Sasha. Is IPCC now puts sort of risk as a combination of hazard, exposure, and vulnerability. I'm not sure exactly how I feel about that, but because there are quite a few different, but it does raise the question for me. This analysis basically comes, is very strongly related to risk and vulnerability. So and that relates to this question. And then, in the Netherlands, yeah, we switched in the way we deal with investments, how we look at them for our flood prevention, to more of a risk-based analysis and saying, okay, what are the costs in flooding, in terms of flooding? And yeah, Rotterdam is going to be much more expensive if it floods there than if it floods somewhere in the central Netherlands, where it's agriculture, and hence, they changed the way they did that from a pure statistical analysis to a much more comprehensive analysis. But still, I feel, as Irina pointed out, it's a bit of a gray area here. It feels a little bit like magic almost, it's like an art in how to deal with this. So how do you make it tangible, and how do you show that this is actually worthwhile? Because you're talking about such big numbers when you do an investment that it's not always possible in our lifetime to actually get a proper assessment.
Yeah, no, that's the question, and to some extent, Irina, she asked a very good question, and to the point. We need to find past evidences, and I think in case of New Orleans, we would find case of inactions because information was there, and we can reconstruct what information was there and build kind of counterfactual scenario what would happen if information was used properly and we use this methodology. And that's one. Second, to some extent, I would say we cannot avoid using real option analysis because if you like to make adaptation part of mainstream of development strategy, and I'm afraid we must, then you need to express benefits of adaptation in a language that understandable for investors. And investors would understand the cost of capital and return on investment. In any case, they would do some projections of return on investments. And the question is, if they're gonna do those projections without taking into account value of information, or with the value of information, and that's the difference. And well, yeah, it's not a magic, of course, but it requires quite significant organization of available information, identification of some information gaps, and gathering additional information. And as soon as you organize your knowledge and present your knowledge in a form of probability distribution or event tree, then you can use those powerful formal methods. But if you don't have knowledge, if you don't have information, you shouldn't even try to come up with probability distributions and try to use this kind of evaluation methodology. So first foundation is your knowledge, and this decision-making framework just help you to organize and transform your knowledge in something that you can later apply sophisticated methodology and then communicate to investors, to policymakers in the language that they would understand. Because if you will come to investors and start to talk about soil moisture index and climate sensitivity and other factors that determine hazard, vulnerability, exposure, then it will be quite difficult for investors and policymakers to understand how they can use this information. They'd like to look at benefit and cost ratio. And in case of really catastrophic events, you use completely different methodology, like robust decision making. Sorry for that long answer to this question.
Seth, you have your hand up and you have your mute on, so unmute, please.
Thank you for letting me know. This question is a little bit off topic, but while I have so many scientists in front of me online here, I do have a question. The video that many of you may have seen of the avalanche, of the glacial collapse that was captured on video by a British tourist really shocked me. I wasn't thinking that glaciers were going to peacefully recede and release their water gradually over time. And now I understand that no, that's not the way it always works. And I'm wondering what modeling has been done to estimate what percentage of glaciers are vulnerable to collapse, and what this makes, if this idea of a sudden loss of reserves has been taken into account in the forecasting and the models that have been developed.
Anybody want to venture an answer to that? I can't.
Because if we have 20–30% of our glaciers collapsing instantly and all the water running out, I mean, we got to be building reservoirs really fast, is my feeling. Try to capture some of that runoff.
Anybody feel like they can add to that, Peter?
Well, I think it is a complex problem. I cannot, because I'm not a glacial expert, but I am a hydrologist. It's not as simple in just building reservoirs, right? That wouldn't be solving the problem in this case, because that water is just going to be once in time is going to melt down. It's going to fill up the reservoir, and that's it. And then it's going to empty the reservoir. So that's not the the answer to that issue. I know there is research done on collapsing reservoirs. There's also research done on lake breaches, which are related to glacial melt, etc. But I'm not familiar enough to give any numbers on that. But I think the problem of water conservation is a global one right now, where we see that we're shifting from a glacial melt to a more precipitation-based regime. And how do you retain water? And that's not just a problem in mountain regions. It's also a problem in the Netherlands, for example, where you're in the flatlands. And how do you now in summertime retain water? And how do you change your agricultural practices to do that? They're difficult questions, and they vary in approach on where you are and what is feasible. But how would I say it? Basically, there is not one single solution there, and yeah, it's not really an answer to your question, but it is not. There's no simple answer to that question.
I hope the glacier people are thinking about this seriously.
But I think that Peter raised a point, and Sasha, I want to see if you have any comments, and then some of our field people who are on tomorrow. So see if you have any thoughts about it. But you need to adapt to the long-term hydrologic regime. And so, as Peter mentioned, if it's less snow, more rain, the glacier may collapse, but you're not, but as he said, that happens and then it's gone. But what is the precipitation regime ongoing? So, and I think this is where really efficiently thought out in adaptation investment is so important. And so what do you really want to adapt to? And I think that's a lot of what Sasha was talking about, was how to consider the uncertainty along as part of your investment strategy. So
yeah, exactly. And point is here that something we know that is gonna happen, and that's what Peter was saying about. And we can use uncertainty analysis to figure out what to do with agriculture. As for glacier collapse, that's a little bit different. That's a question. Is it going to be a synchronized meltdown, or it's going to be here and then there? How it's going to happen? Because, well, in terms of water supply, reservoir wouldn't help, as Peter pointed. But if sudden losses of irrigation water would happen this year in one place of the world, next year in another place of the world, then there should be different strategy, like storage of agricultural goods and so on. It would help. But if it's going to be a synchronized meltdown, then it's not going to help. And how this collapse of glacier would happen, it's I think it's $100 trillion question. Yeah. So anyway, I think each analysis has, each instrument has its limitation. In case of glacier collapse, that's probably should be a jump diffusion model with gamma processes embedded in that, but it is up to climatologists and specialists in glacier dynamics before people who's dealing with decision-making theory can take that on and see what to do about that.
So
Yeah.
Seth, you wanted to add something, and then we have about 5-6 minutes left. So I see Peter has his hand up also. I'd like to see if anyone else who hasn't said anything would like to hop in after Seth. So go ahead, Seth.
Yeah, just a brief comment, obvious, I think, probably to everybody, but if our politicians are thinking that peak runoff is going to happen in 2050, but a model of including glacial collapse indicates that in effect, we're going to be running out of water in 2040, they need to know that they got to accelerate and treat this as more of a crisis, an urgent crisis. If we're going to run out of water countrywide sooner, that's critical for them to know, for the politicians and the investors and lenders to know. Thank you.
Okay, Peter, hang on 1 minute. Does someone else want to add anything or have a question? Any of you guys who are talking in the second panel, is this, or do you want to think about it overnight, what you might say the next day or so? I like putting people on the spot. It's one of my jobs here. So.
I was actually going to do that, Michael,
Okay.
because I remember from our previous workshop, we had a few experts here that I see on riparian stuff and, talking about changing regimes. So I'm really curious how they see this, right? Because you want to conserve the environment, that's for the down, but with changing water availability, as I remember some of you talking about that, there is this really strong tension in trying to preserve what you have, but you know that the environment is going to change around it, particularly with water, with respect to water. How do you see your solution space? That's my question, right? Because you cannot hold on, things are going to change. So how do you see in Central Asia that solution space? And that's I think I know I'm putting
it's all right.
people on the spot here, but it's really curiosity from my side, right? I'm looking at this, I see this, I'm like, yeah, I know what you want to try to achieve, but yeah, in 20, 30 years, there might be a completely different regime there. How do you deal with that as a researcher, right? I'm looking at living now in the Rockies. I see how drastic that change can be. Hence, I can only imagine how similar it will be in that region.
Okay, don't worry, guys. You can, Florian, Magdalena, it's only 3 minutes left. You can say something. Okay, one of you, turn off your mute. Okay, Florian, thanks.
As I think maybe the most crucial thing to talk about or to imagine is that these riparian ecosystems, they depend on dynamics. That's the most crucial thing. And I mean, as long as we have certain dynamics, I think that these ecosystems will adapt. Crucial thing to really threatening these ecosystems is to reduce these dynamics, as you might do, for instance, if you create a hydropower dam. You will disturb dynamics from 1 year to next year, or maybe within 3 or 4 years. And so within this short period of time, the ecosystems don't have any chance to adapt. You will disturb a hydrological regime and something what is maybe not so much in mind, to disturb sediment regime as well. And so these sudden changes and dynamics definitely will cause tremendous threat on these riparian ecosystems. So if we think about this natural flow regime issue, and if we have a look at the past 70, 80 years, so the period we have observations of the hydrological stations, we do not see any significant change in the flow regime. We see some change, of course, in the amount of discharge, but the general flow regime didn't change so far. This might change, of course, if we go from glacial regime to precipitation regime, of course. But I think if it's enough time, I think the ecosystems will adapt. Really, environmental issue is if we have sudden changes from anthropogenic interventions.
Okay. Well, unless someone has something very urgent as the moderator, I would just like to thank everybody, our three speakers, for very interesting presentations, which kind of frame this whole issue of climate adaptation and the various interesting comments we got. So thank you, Seth. I'm glad you joined us. And those of you who are in Bishkek, my personal best to Bishkek. Sorry we couldn't make it in person this time. And our emails, hopefully all the emails of all the participants will be distributed so we can stay in touch with each other, and good luck with tomorrow's panel. So unless there's anything else anyone would like to say, I will sort of consider this officially over. So thanks again.
Thanks again.
Spasiba, Rahmat.
Goodbye.
Thanks.
Thank you, everyone. Bye-bye.
Ciao, Rahmat.
Thank you.
Bye.
Goodbye.
Thank you.
Bye.
Thanks, Mike. Bye-bye.
Bye.